All right, this is part 2 of our review for test 3. I didn't actually finish number 10. We still have part B. It says, how many people have a math class or an English class? Now remember, with or, we're looking at the people that are in the math circle and or the English circle or both. So basically, I use the word combine. We're going to combine the two circles together. So everybody in the two circles gets counted. So that's going to be, so this is, again, or is treated like union. It'll be 13 plus 15 plus 6, which is 34. All right, let's move on. So on number 11 here, it says for set A, or for problem A, that we need to draw two disjoint sets. Now remember, disjoint sets are sets that have no members or elements in common. And so it would just be two circles. I'm going to say circle A and circle B, and there's no overlap. On B it says draw two sets in which one is a proper subset of the other. So I'm going to go ahead and draw set A in circle A inside of circle B. And so that means that A would be a proper subset of B. So my circle A is inside my circle B. So every element in A would be an element of B. And they're also not equal sets. And so that's what it means to be a proper subset. All right, let's look at number 12. So we did one of these earlier with just two sets A and B. Now we have three sets A, B, and C. So U is basically the set with Q through Z in it. A has Q, S, U, W, and Y in it. B has Q, S, Y, and Z in it. And Z has V, W, X, Y, and Z in it. So B complement, that's our first problem, problem A. B complement is everything in set B that's not included in the universal set. So we've got Q, S, Y, and Z. So Q, S, Y, and Z. I'm going to cross those out, and what's left goes in B complement. So that would be R, T, U, V, W, X. W and X. Okay, so let me erase. Let's move on to problem B. So in problem B, we need to find the complement of A intersect B. So first of all, let's find A intersect B. Well, those are just the elements that A and B have in common. Well, Q and S and Y, it looks like. So let's go ahead and put those in. Now the complement would include everything in the universal set that's not in set A intersect B. So let's go ahead and cross off Q, S, and Y, and what's left over would be R, and then T, U, V, W, and X, and don't forget Z. All right, let's move on to part C. Here we have to find A union the intersection of B and C. So notice B intersects C is in parentheses. I would find that first. Now I'm going to go ahead and write set A, and then we're going to union that with B intersects C. Notice, let's see, we need to look at B intersects C. So what do these two sets have in common? Well, notice it's just Y and Z. So I've already put that down here. So now, to union these two sets, remember we just write everything in the first set. That would be Q, S, U, W, and Y. And then we need to add to that anything in the other set that we don't already have. Well, that'd just be Z. All right, let's move on to the next problem. In number 13, it says, the chart that follows shows people's loyalty to specific grocery stores. In the Venn diagram given, the set indicated as 1995 represents the set of grocery stores listed in the table under 1995, and so on. So basically, for the years 1995, 1998, and 2000, we basically have people's favorite stores. So sometimes stores made the list, and other times they didn't. So it says, determine which region 1 through 8 each store belongs. Determine which region 1 through 8 each store belongs. Okay, so let's see. I've labeled the circle with the different regions. Now for Sloan's, notice Sloan's made the list in all 3 years, and so Sloan's should be in all 3 circles. That puts it in region 5. That's the overlap of the 3 circles. That's our inner region. So for Jim, part B, notice Jim only occurred in 2000. So in 2000 we had Jim, but it wasn't a store listed in 1995 or 98, so it's only going to be in 2000. That's region 7. All right, I'd like you to try one other one. Go ahead and see if you can figure out where Koffs would go. Koffs, Koffs. All right, so if you look at the chart, Koffs occurred or made the list in 1995 and 1998. And so we need to go to the intersection of 1995 and 98. So that would be here, not including the middle region where that's for stores that made all 3 lists. And so that would put Koffs in region 2. All right, let's move on. On number 14, again, we're going to do, we're going to construct a Venn diagram where we have a Venn diagram with 3 circles. So we have 3 sets, A, B, and C. So let's see, remember we want to work inside out. So first of all, we want to put in the elements that are in all 3 circles, or all 3 sets. So we're working inside out. So that it looks like 2 is the only number that's in all 3 sets. And so 2 goes in the middle. And then we're going to work our way out where there's overlap between 2 sets, not including the part that we already filled out. So for the intersection of A and B, well, let's look at A and B. What else do they have in common other than 2? Well, notice 8 is in both, and that would be it. And so 8 goes in the 8 goes in the intersection of A and B that doesn't include all 3 sets. Let's go to B intersects C. So that would be this region here, or the overlap between B and C. Well, again, we already have 2 in the middle region. That's where 2 is in all 3 sets. So what else do B and C have in common? Well, let's see. It looks like 10 is also an element they have in common. And so 10 would go in here. Whoops. All right, and let's look at the intersection of A and C. Now, if you look at A and C, the only thing they have in common is the 2 we already found that's in all 3 circles. There's nothing else they have in common, and so we won't be adding anything else to the overlap of A and C. Now we're ready to fill out the rest of circle A, where we don't have overlap. So we already have 8 and 2, so we're missing the 4. So 4 goes in the part of A where there's no overlap. Let's move on to B. So we already have, in set B, we have 2, 8, and 10. We're missing 12, so 12 goes in the part of B where there's no overlap with any other circles. And then finally for C, notice we already have 2 and 10. We're missing 6. So 6 goes in the part of C where there's no overlap with the other 2 circles. Now we're not quite done here. Don't forget, we need to look at the universal set and add anything and go outside the 3 circles that we don't already have. So what are we missing here? That would be 3 and 5. So 3 and 5 should be in the rectangular portion of the Venn diagram outside the circles. All right, let's move on to number 15. It says in a survey at a shopping mall, 120 people were surveyed to determine their preferences for stores shopped. Now this is a Venn diagram with 3 circles, and basically we're going to use this information to fill in the Venn diagram. So again, we'll work inside out. So we actually end up going from the bottom here to the top. It says 12 shopped in all 3. So we're going to put 12 in the middle where we have overlap here. Then it says 40 shopped in JCPenney's and Sears. So if you look at the overlap for JCPenney's and Sears, that's here. There should be 40 in there, and we already have 12. So if you do 40 minus 12, you can see there'll be 28 in there. So we are done with these first 2. Whoops, let's fix that. Now we're going to look at 32 shopped in Dillard's and Sears. So Dillard's and Sears, the overlap is right here. And we already have 12 in there, and 32 should be in that region. So if we take 32 minus 12, we get 20. And so there's going to be 20 people in here. Next, let's look at the intersection. Let's see, it says 37 shopped in Dillard's and JCPenney's. Keep messing that up. Let's see, 37 shopped in Dillard's and JCPenney's. So if we look at the overlap for Dillard's and JCPenney's, we already have 12 in there, and there should be 37. So if we subtract 37 minus 12, we get 25. So 25 more would go in there. Now we're going to move up to the next statement. It says 67 shopped in Sears. So now we're ready to complete the Sears circle. We already took care of all our overlap. So there's 67 that shopped in Sears. If we add up the 28, 12, and 20 that are already in there, we get 60, but there should be 67, so that means there's 7 more. So 7 in the Sears circle where there's no overlap. All right, and next it says 71 shopped in JCPenney's. Well, if we look in the JCPenney circle, we already have 28, 12, and 25, which is 65. And there's supposed to be a total of 71 in the JCPenney circle, so subtract 71 minus 65, and you get 6. All right, we've got one more to go. 62 shopped in Dillard's. So in the Dillard's circle, there should be 62. We already have 25, 12, and 20, which is 57. 62 minus 57, you get 5. Now don't forget, there's one more region we need to find. That's outside the circles. And if we add up everybody in the JCPenney circle, the 6, 28, 25, and 12, and then we also need the 7, 20, and 5 outside the JCPenney circle, in the other 2 circles, we already have represented 103 people. Now that means since there's 120 total, if we subtract, there's 17 basically don't prefer any of these three stores. So 17 outside the 3 circles. So now that we've completed the Venn diagram, we can answer the questions. So on A it says, use the Venn diagram to determine the number of people who shopped in. Well, A says only Dillard's. Well, only Dillard's, that's going to be the 5 where there's no interlap. So that would be 5. It says, let me see, I need to erase this here. Oops, I lost my 5 there. Okay, so exactly 2 of the stores. Well, exactly 2, that would be in these areas here. So 28, 25, and 20, these are the people that chose exactly 2 stores. So if you add those numbers up, you get 73. Letter C says exactly 1 of the 3 stores. Well, exactly 1, that would be the 6, 7, and 5. These are the people that shopped in just favored just 1 store. So if we add those up, 13 and 5, we're going to get 18. Letter D, Sears and Penny's but not Dillard's. Sears and Penny's but not Dillard's. So Sears and Penny's, the overlap would be here, but throwing out the people that were in the Dillard circle, that would be these 12, we get 28. Sears or Penny's, now be careful, this time it's or Penny's, so let me change colors here. So Sears or Penny's, we're going to take everybody in the Sears and the Penny's circle and combine them all together. But we're not including anything that's in Dillard's, so we're going to cross out these guys here. So that leaves 6 plus 28 plus 7, which is 41. All right, and that is it for this review.